you and I.
Basic that goes in the DNS. First thing I want to do is basically get my clients to talk to each other. So I'm going to start by basically checking some basic connectivity here. I'm going to do an ifconfig on the client side to my Ethernet interface. And I'm going to see that I'm on the 192.168.92.128 network. Next thing I'm going to do is pop over to another server VM. This just happens to be an unpatched server. And I'm going to look at the different properties for my network adapter card just to make sure that I'm on the same network and I can actually talk to each other. So I'm going to do that by going to my local area network properties and checking my IP address. Now, this is a statically assigned IP address to a server on the same network. We know that because it's all 255s here. So anything with 192.168.92 is all on the same network. I'm going to point to myself as the default gateway. I'm also going to use myself as my self DNS server, and then everything else I'm going to forward on to Google DNS on the server. So basically I have a client on my left, I have a server on my right, it's a vulnerable Windows 2000 server just for the sake of showing vulnerabilities and things like that. And then I want to test the connectivity. So we're going to go ahead, and it's convenient to have your screens like this because that way you can see, your IP address on the right, over here, while I'm typing it on the left, right? So just make it real easy for yourself. Scatter your windows, type in your IP address, 192, that's 131. Go ahead, ping it, make sure you got some basic connectivity, and I'll just cancel it there. And then we can go into interactive NS lookup mode, okay? Now we can do some basic things over here from a Unix terminal, okay? You do get different results, as I'll show you in a second, from a Windows terminal, so we're going to kind of compare apples here, left and right. So I'm going to simultaneously work this exactly the same thing, both Windows and Unix. So ping 192.168.92.131 and make sure I got connectivity. So now I know all three are talking to each other, and that's fine. Let's clear the screen for simplicity. All right. And then I can get in interactive mode just to make sure we're on the same page. Let's look up. Okay, great. So let's go back over to the Kali client virtual machine. First thing I'm going to do as a client is I'm going to set my server to specifically talk with this vulnerable version of Windows 2000 and Active Directory. Because this is also a DNS, but it's also Active Directory integrated DNS, and I'm going to show you an extreme vulnerability here when your server is configured as such. I'm also going to show you the exact opposite side, the defensive side, and how to secure this to prevent this type of reconnaissance from happening. So let's go. So I'm going to set my server to the server that we want to interrogate. So in this case, it's 192.168.92.131. And I specifically want to use the IP address here, not the fully qualified domain name or the domain name of the server. Okay. And then we're just going to basically test a basic query. So the server's domain name happens to be vernet.com, and I want to make sure that I get local addresses here. If I were to get something like, a public address, Basically what I'm looking for is 10 networks, 172.16 networks, and 192.168 networks. That proves to me that it's internal. Also, anything outside of that would be public, so I know I'm talking to the internal server as opposed to the external server out on the internet somewhere. So I'm speaking to the right server. Same thing happens over here on the Windows side. Server 192.168.92.131 is our address. We set it, and we do a vernet.com. And I get 192.168 results, so I know I'm talking to the internal one. Now back to the Kali client. All right, so now we're going to look for specific record types. So I'm going to set the type is equal to MX, and if you get your return back, nothing errors out, that means you've typed it correctly. There's only one space in here. That's it, and it's type equals MX, and MX is for your mail records. Okay, so now if I do a vernet.com, okay, it'll tell me what it can find basically for a mail record, and we can compare that simultaneously over here on the Windows client. Okay, set type is equal to MX and vernet.com. Okay, now in this case what you're actually getting is not the mail server but actually the start of authority record. This specific piece right here looks just like the start of authority, and I can prove this by just setting the type equals to the SOA record and basically doing the same thing, vernet.com. Okay, and you'll see that the results are pretty much identical. So here's what it looks like for the mail record. After I set it, pretty much looks exactly the same. So I know I'm getting the equivalent. Okay, so in this case I don't have a mail server connected to this. But there's other reconnaissance we could do to try to find out if and where mail was being integrated to. So the same thing over here. I'll do a set type is equal to SOA vernet.com, and I basically get the start of authority record. Okay. Now let's translate this. The origin is 23.att.vernet.com. That's actually the server name, and I can prove that just real quick if I exit out of interactive mode and do a host name. Okay. Actually, that's the Windows client, so that's how I know it's wrong, because that says Obi-Wan Kenobi, and we want to check it on the server, so let's actually just do it in the right place. Open up the command prompt, host name, 823 ATT, so servers configured for the host name correctly. All right. The mail address, the email address at a specific domain, the serial number, the refresh rate. This is how often in seconds does the secondary server query the primary server, and if that query goes wrong, we should retry every 600 seconds from there on after, up into a period of 86,000 seconds, and then it'll stop answering name server requests. Okay, so that's basically how to translate the start of authority record. Also be able to convert, seconds to minutes to hours, because if you compare this over here to the Windows client, NS lookup, set type is equal to SOA vernet.com. Okay, notice this is slightly different. They actually have in parentheses that it's 15 minutes or 900 seconds, or 10 minutes, or 86,400 seconds, which is always a great number because that's the number of seconds in a day. One whole day right there. So Unix doesn't tell you that in kind parentheses, Windows does. Okay. Also says that you're connected via the server address record, specifically right here at the end. Now that's all in good, and we can continue to poke around and look at different record types. So if I do a help over in the Kali side, I don't get any. Typical other options would be something like TAC A. That doesn't work here. Or question mark. Okay, so in this case, we don't get too much help on the Unix side, but we do over here on the Windows side. All right, so I'm just going to use the help over on the Windows side. There's different, I gotta clearly look at the manual page for the Unix to find out how to actually use the NS lookup command, and just demonstrate that right quick. You would basically do a manual space NS lookup. You can see you can go into that, and then you can colon Q to get out of that, and then get back into NS lookup. So it's there if you wanted to access it, but that's not the purpose here. So over here, to look at the help file here was the set type is equal to. But one of the things that I like is it actually tells you all of the actual record names in this particular terminal. All right, and that's pretty helpful in the grand scheme of things, because you can see, I'm trying to move the window here. You can see that you got your host record here, which is your A record. You have your mail record, which we looked at. The primary name servers, or the person responsible for the domain. The pointer record, which is the reverse name to IP. This is IP to name. The start of authority, which I just covered, or any sort of service records. So one of the things that I would be looking at specifically is the service records. Right, so I would set the type is equal to SRV, and then do the same thing again, vernet.com, and see if anything comes up here. And it does say NX domain here, but not really that great of a result. So as you can see, so let's try it over here and see how it differs. So it would be set type is equal to SRV, and then let me see if I can't resize this for you. And then vernet.com. Okay, and you can see that I don't really get too much in terms of service records here, but that's not the end of the game yet. So it just looks like a regular server from basically this side of life. But let's see how far we can't push the envelope. So let's do an ls-d, which is list the domain for vernet.com. But look what I get here. Look at all this stuff that just dumped to the screen. Okay? These are all of the internal Active Directory records. So even from the outside, it may appear to be just a regular, name query and just getting some basic, records like SOA and host name and service record and things like that, or mail record or whatever you're looking for. When I actually try to transfer the zone, I actually get the complete client mapping here. I get all of the host records. So the reason why this is such a powerful exploit in terms of reconnaissance is instead of setting the type and getting one record at a time and trying to enumerate one record at a time, by transferring the whole domain to yourself, you literally get Pandora's box. I get all the server records, I get all of the host records and more host records. I can tie that to different priorities and weights, and This is specifically for the global Active Directory global catalog, and Kerberos for logging on, and kpassword, and the LDAP directory information. So Kerberos, so I clearly am getting internal Active Directory services, which is great. I can also see some additional host records that are basically bogus records that I created, basically for the purpose of the demonstration. I also get the IP addresses of these records, and you notice these are actually on another network. So I've actually questioned that and make sure that I document this. Which, speaking of documentation, you can easily, if you're in edit mode is over here in the console properties, quick edit mode. If you're in quick edit mode, then you can just basically click in here, hit enter, open up Notepad, and then control paste, and you can see it pasted exactly what I just copied. So that's a great place to store all of your notes that you would need for if you're documenting any sort of penetration testing report, whether white hat or gray hat or black hat. Make sure that you do your documentation. You know, as a trainer, one of the things that I look for is, one, can you actually do a skill like this? But as a professional employee, if I task you with this task to go bring me back this reconnaissance, you also need the ability to write a report and basically document this yourself. Capture that documentation and supply it to somebody else. So please don't forget to document, and document as you go. Because every step here I would record and document, and that way when I go to write my report, I have all of the copy and paste stuff that I need to basically move forward and illustrate for the purpose of a vulnerability scan or a penetration test. Okay. Now let's compare that to what we get over in the Unix side. ls-d vernet.com, and it says, oh, the ls command is not implemented. So what that tells us is that you're not going to be able to actually just transfer the zone as easily with regular NS lookup as implemented in Kali. But don't kid yourself yet. There is still other tools you can use. There's the dig utility. So I just did the manual space dig and opened up this file, and this is for the DNS bind version 9. And you can get an idea, and please, get used to self-learning this stuff. Read this stuff yourself one time and get the idea. So dig, just real quick, is domain information groper. It's a flexible tool for interrogating DNS name service, and that's about all we need to highlight here. So if you want to know what specific instances of the commands are used, like here's the server command, okay, here's the type command, and then if you're lucky, in most manuals, they actually give you how do you actually use it. So in this case, it's just type equals any, and any other additional options that you possibly could include. And this, you want to get advanced, you want to start learning some of the advanced stuff, you certainly could go through and look at some of these specialized circumstances. So I just want to point out that they're there, and several of them at that, right? And you can scroll all the way down, or you can do a control Q to basically get back to your terminal. So that's a basic configuration offensively as a penetration tester, what you would be looking for if you were trying to integrate or interrogate a DNS server, more importantly, one that's tied to Active Directory. So let's think defensive for a second. Let's figure out how will we actually solve this problem and shut this off from the client. Well, one of the things you can do is just go right into Administrative Tools, open up DNS, and again, we're thinking defensively here. Open up your your domain, right-click the domain, go to Properties, and look at Zone Transfer Information. And in this case, because this is a vulnerable server with several default settings, which should have never been allowed to be authorized to operate, or has never been STIG or has never been hardened, which is likely to what you would see in some environments. I don't necessarily care that this is a Windows 2000 server. I'm just realistically using that purpose for the illustration. If you have the latest and greatest server and it's still configured the same way, you are vulnerable. So I'm going to shut off zone transfer, or I could have selected to only the servers listed on the name servers tab, so I'd have to have that server here, or only to the following IP address, like another DNS server or something that needs replication. Otherwise, for the purpose of the illustration, I can just turn it off completely. Click turn it off. Let's go back to our terminal and do an ls-d vernet.com, and you can see query refused. So it's the query refused, which is really the takeaway here, because basically that means administratively refused. It means there's a setting in place that's actually restricting me. It's not that, what results did I get back and were they really the right results. In this case, I'm specifically being told you've been administratively blocked. And that's how I'd basically shut this vulnerability off and harden the server or for anything that would be, DNS integrated or Active Directory integrated, and how I would prevent just a rogue client from interrogating those records on a network and basically being able to pull, at the end of the day, the whole client table from the server. Again, that includes all the records, both server records and client records. So what we did here, to summarize, is we made sure our clients were on the same network. We used 2 separate client shells to connect to one vulnerable server, and we did the same commands side by side from the client. We interrogated the server, and we basically got to the point where we could transfer the whole Active Directory integrated DNS table down to a client and basically have a complete map of an internal network. And we did that relatively easy. I didn't have to run Nmap. I didn't have to scan the whole network. I didn't have to use advanced pen testing tools. I basically have only used the traditional network administrative tools, and then a Kali client, which is probably one of the most well-known pen testing clients out there. I did them side by side. I queried the server. I pulled down the zone table, and then I switched defensively to show you how I could have stopped this. So hope you enjoyed the video. Lots more to come. Don't forget to check us out.